Okay, the first thing I want to do is I want to get the full width of the flange that I'm going to be putting inside here. So I'm looking at that's about 1 inch 430. I want to make it a little smaller than that, of course. Probably if I made a 4 inch 400 should work for that. I'll start at a 1 inch 400 thou. Okay, so I'll just lay my calipers on there and just make a line here and a line here. I'll extend that line up. That will be the full flange diameter right there. Less than 1.5 inch stock should work for that. Now, the next thing I need to check for is that 1 inch 400 thou. Is that going to give me enough to get rivets in there? Yes, because the flange is going to go down inside here. That's where it's going to go, and then I'll be drilling through here and pop riveting through here into the flange. So at 1 inch 400 thou, that still gives me enough to be able to get rivets in there. I have to use smaller rivets, of course, but I can still rivet that into there and have enough room around here to rivet that. Now I need to think about the thickness of the flange. And here's a 1/16, here's an 1/8. I'm going to go with an 1/8 inch and see how that works with an 1/8 inch thickness for the flange. 1/8 inch thickness. I think that will work. Let me get a rivet and see what that will look like. Okay, that 1 inch 400 is like 1 3/8 roughly. So that I can center this at 11/16, and that will be my center line. Okay. And now I'll work on this diameter here, and then this internal bore here I'll work on and get that drawn up. Okay, this diameter here is 810 thou. So I can go at 810 thou, so it would be 405. Okay, that'll be 405 off center. That'll be the diameter of that. And I have another diameter below this yet. Now this is the top of the flange here. That's the bottom of the flange. I could go below this now. The distance of this here offset from where this here broken flange starts and where this here part here ends. So what I'll have to do is I'll have to get this here from here down to here, get that thickness, and that's how much that protrudes down. And that part sits on top of the bearing that's on the motor shaft. Okay, I have this here old flange from the part that broke off here. I got that flipped up here as much as I can, and what I'm going to do is I'm going to take my surface plate here, my height gauge here, and I'm going to take that height measurement to the bottom of that, which is 380, about 375 it looks like. We can call it 375 to the shoulder, 360, 370. Where that's sitting at, right here on top where that flange is actually sitting at, 375. And then if I go to the top here of it where it protrudes out, that's 375 on the bearing part, and on top we're looking at 450. Okay, so that means that when this flange is sitting inside here like this, it was sitting here on the shoulder here at 375, and then this protrusion is at 450, so that is 375, 4, that's 25 plus 5, that's 75 thousandths. So that's 75 thousandths below this here area here. And on the drawing here, that would be right, this flange will be sitting here. This here is sitting on top of this. So it'll be from the bottom line here down 75 thousandths. 75 thousandths down from here. And then I will take the full from 75 thousandths. I'll come up that 450 or that 400 or that 450 thousandths up, and that will be where it would stop up on top. So what I need to do is I need to come down from this line here. Now I need to come down 75 thousandths. That 75 thousandths is the protrusion below. Would be the protrusion below. This is the part that actually sits on the bearing that's rotting on top of the shaft, and now I'll come up that 450 thou from that line there. From that line there, now I'll come up that 450 thou, and that will be the top of the flange, or the top of the that bearing part there, and it'll be just like that. Okay, so that'll go across top here and stop there and stop there, and then it will come down here, and now I have to get that there diameter across the bottom here now, and that diameter is 615 thou. Of course, all this will be done with mother measurements. My actual tooling, whenever I do the actual measurements, is to just get it roughed out here on paper. And so that will come up now. There. There. And so now we have all this established here. All the way across. You can see there or not. Okay. Alright, that's that part drawn up. Okay, and one last thing that's very, very critical, very important, the inside diameter. This is what goes over the shaft itself. What I'll do is I'll check the actual shaft itself on the motor shaft with my micrometers. This just gives me a rough. Okay, so I'll just roughly get this back in there too. Off the center. Off the center. And that'll be the internal bore. And that'll be flange itself is a thickness of 1/8 inch, 0.125 inches. The bottom part of this here is outside diameter at 5/8 inch, 0.625. We'll give it 5/8 inch there, and that will be the whole part made right there. That will fit inside. That'll fit inside here, and then we'll get riveted to this. And then I will initially turn the workpiece to 1 inch 450 thou, which puts it kind of tight in here, and then I can turn it down enough to be able to fit that inside here. And then after I do that there, then I can start working on these other dimensions over here. Okay, it's time to go to the lathe, and the first thing I need to do before I make this piece is I need to make the shafting, the shaft fixture that I can use to test this whenever I go to do the boring here, as well as to use that in my tailstock to press this into the fan. So that's what I'm going to draw up next. I'm going to draw up the shafting now, the shaft fixture. Okay, I need the shaft fixture to go below here, to come up through here, to have a flange on it so they can push this in, and then to be turned down to about 3/8 of an inch in diameter to be able to fit into my tailstock chuck. Because I have a 1/2 inch chuck, and I can't put this is 800 thousandths of an inch wide here, so the diameter has to be cut down even less than a ½ inch, just to be able to comfortably put that in my chuck. So that's what I'm going to draw over here now. I'm going to draw the shaft fixture. Okay, so I'm going to come down below here, so I'll just go ahead and draw that in below. Then I also want the shaft to come up to here with a flange. I'll come up about 1/8 inch past that. So now 1/8 of an inch past the top here. And then the diameter of this here now has to be that their inside diameter here. Then I'll just make this flange about 1/8 of an inch in thickness. It can be anything it wants to be. There's no problem there. And then I will bring this down now to 3/8 of an inch to fit inside the tailstock. So there's a center line. And then I'll come down to 3/8 of an inch. The shaft that will have one end of it here that will fit through the part that I'm making. The flange bushing will fit through here, and then it will have a flange on top of it that will be used to push that down into the fan itself, into the headstock, and then on top of that will be part of that will be go inside the drill chuck itself. Then 390. So I'll open it to 385 first, and then open it as need be to get this to fit on there. That's I'll just make it 390 for starters. And the same thing here, that's 390 thou, the outside diameter. And then I'll open it up a little bit as I go along here to make this fit onto this here, which is about 393, 4 around there. Alright, I'm ready to start making this here shafting here now to fit this, and then to start making the actual flange bushing next. So what I'll do now is I'll go ahead and I'll make this here shaft fixture first, and then I'll make the actual part next, and I'll bore that to fit. I'll make the shaft fixture to fit inside the internal bore of this right here.